Okay, I guess as the group is getting off the stage, I'll introduce our closing keynote speaker. Rafael, I'm very honored to introduce Rafael Bras. To tell you a little bit about him, Rafael spent 32 years at a little school back east, which is pretty respectable, called MIT. They try every once in a while to compete with us here at Caltech. And he was professor, head of the Department of Civil Engineering, as well as the chair of the faculties. And I think a few years ago, he got tired of that cold weather back there and decided to move to the Golden State of California, and he's now the dean of the Samuel School of Engineering at UC Irvine. But also, Dr. Bras have had a long, distinguished career contributing to the whole field of engineering and science. He has been on many advisory boards, including the NASA Advisory Council and the NSF Advisory Council. He has received numerous awards, including the NASA Distinguished Public Service Award, as well as AGU Medal or Horton Medal of the AGU. He's a member of the National Academy of Engineering, published many hundreds of papers and a couple of books. But I was telling him earlier, probably the one that particularly impressed me is his unique effort of chairing the committee, which is looking at how to save Venice by making it by a major engineering project of how to protect, that great cultural, city. So with this, please join me in welcoming Professor Bras.
Thank you, Charles. Good afternoon, everybody. Let me begin by saying that it's truly a pleasure to be here and thank the Keck Foundation for sponsoring this, certainly, and JPL and Caltech. I was joking with Jean-Loup a minute ago, whom I've known for many years, that I have been in Caltech only once before, and it was really in passing. And I think, I'm trying to think, why is that? They've never even invited me. Maybe it's why what you said, but the real reason is that we stole their cannon. They had to go back and get it. But anyway, as you've heard, I am certainly here in California for a year. I'm certainly enjoying it. Like they say, timing is everything, but what can I say? Let me begin with something that is going to be a little bit of a joke, but it's also serious. I was going to actually take my jacket off and put this on, and I hope everybody says that. It says, I need my space and NASA. And I just couldn't resist it, because yesterday I was, waiting to get to the airport. I went to the Kennedy Library in Boston. And needless to say, since Kennedy was instrumental on setting up the goal of going to the moon and setting up NASA in its exploration successes, they're very big on this. So when you see that shirt, it evokes all those glory days of NASA. But to somebody like me who have been involved for so many years with NASA in Earth systems and know what else goes on, it's a little bit frustrating. By the way, I'm a pilot. I would love anything to go on the space shuttle or in anything they send me. I'll take it. But the success of NASA with the Earth Systems Observatory and the 15 satellites that are flying out there is really, really a revolution. Somebody called it somewhat of an evolution earlier, but I actually think it's a lot more than that. Nobody can compare to what we have flying in terms of assets there. And I recall from at the beginning when this was planning, and certainly Berrien was there from the beginning, it was truly an extraordinary endeavor, and one that took a lot of courage to do so, and one that has yielded incredible results. I think, and I'm not going to try to list that, but I certainly think that we can do things that we never dreamt of before, that has been said here. We have discovered things that we did not know. And now we can act in ways that we could simply not act before. And a lot of this meeting has been on how do we act? How do we operate? How do we use this information for the benefit of society in general and California in particular? So I think it's been an extraordinary couple of decades. And my frustration when I was chair of the Earth Sciences Advisory Board at NASA, a member of the NASA Advisory Committee, is convincing NASA where's the big next step on the Earth Sciences. What are you going to follow up with? Which I thought we had, and then it was sort of dismantled. And I put Jack on the spot in Washington, D.C. a couple of weeks ago, asking him that question. We don't have an answer. And I am really, really not, I must say, very disappointed at that. Well, let me then move to what I'm going to do. I was asked to do this, and basically they called me and said, would you want to do this? And so Diane and Jack sent me an email, and I thought of it a little bit, and I sent back a note and said, well, what do you want me to talk about? And their answer was, well, we want you to basically summarize, tell what went on during the day. That's your end speech. I said, whoa, okay. So how do I do that? I don't have time to prepare anything in particular. It has to be sort of standing up and do it in real time. And then I thought about it. Look, you've been teaching for 40 years. You've been doing that all this time. So, so anyway, here's what I'm going to do for you. I'm going to literally go person by person and give you a soundbite that I recorded as I took notes of what I thought some of the key issues. And I've heard very interesting comments today that I heard today from individuals, and I try to attribute them correctly. There was a lot of repetition, if you think carefully, which is good. And then I'm going to summarize with what I think are some of the key important messages that I hope we can all go out with. So let me begin. And I'll begin with Mary Nichols this morning when she opened in her opening keynote. Key concepts: how to access data, who takes it, I think I'm quoting, who takes it, how you access it, and how you use it. That was some of the message. Remote sensing, something very important. She says we need to move from the global to the regional. That's a statement that has been repeated. We need to use remote sensing to track changes. And the key operating word is track changes. Changes is a question which brings up the whole idea of do we observe long enough? We need to be concerned about regional issues. On the session of observing globally achievements and promise, Janet Campbell said, actionable science means local efforts. Another key message, and I'm going to get back to that, and many people said that in different ways. And it's a sea change from what a lot of our, let's say, climate change is all about now. When you think of it, and that's what we need. Models. She brought up the issue of models, and many others did, but she did it first. Integration of different models with data, a crucial issue. And finally, a theme that has been repeated, and we heard it again and again now, how do we hand off the NASA data? How do we make it operational? How do we deal with what I dealt for 8 years as chair of the Earth Sciences Advisory Board? The constant issue is, well, NASA is a science agency. How do we develop technology if we then use our budget to take data forever? Somebody else has to do that, and nobody understands it. And I'll address it more seriously or more completely later. But that's a very important point. Brian McClendon, data has to be seen with as many eyes as possible. That was a very nice quote. And I think it's a good one that came around, and you'll see the theme repeating itself with a different twist. I personally would like to call that now and it's common to many of the things said is the democratization of data in some way. That's the way I like to think of this. Berrien started by saying, well, we're talking about California, that's the theme of today, and the topic of California is water. That was his statement. Then he said something very, very important. Data can be seminal on the way that we evolve our knowledge. And he used the Killing record as one record that really and truly is and was seminal, that really and truly made possible the science that we do now. And it wasn't remotely sense, but I think the implication that I think he was also trying to say is there remotely sensed seminal data that can be used the same way. In fact, I think there is. And then he had something very close. He said something very close to my heart that again brings a repeating theme, which is we need to fundamentally challenge the models. And that has many implications. What does that mean? He meant it from the perspective of we need to make sure they work. How do we reconcile the 17 models or whatever number you said that exist at the climate level? But also, how do we challenge them by making the models ingest the data that you obtain from remotely sensed platforms or from anywhere else for that matter? Pete Warden used the words, bring climate change to the individual. That again go local. It's the same type of message. Local climate predictions are crucial. That's where people live. And we want to know about what happens in our lifetimes. The research has to be translated to operation. In other words, what is the supply chain of knowledge in here? How do we begin from the basic information to the implementation? And as I have to say, as a dean in a school that has a lot of biomedical activity, these people have it right. You know, we're in the same building, you go from the basic research in one arm of the building all the way to clinical practice in the other end of the building. How do we do that? How do we create, call that building NASA, how do we create that possibility? Second session was need for actionable science. The need to integrate science and policy was an issue that was brought up, very, very important. Remember, we had the two assembly people here. And I found that, in all honesty, I would say the same thing whether they're here or not. I found it fascinating because I also like the politics. It's sort of in my blood. I'm from Puerto Rico, and you do politics. But I also found it a little disappointing. In fact, if I had given the chance to ask the question from the audience, I was jumping to do that because I think their solutions were simplistic. They were somewhat dismissive to say the problem is yours. I don't think that's the case completely, but they had some very good points. We need to integrate science and policy. Absolutely. The system is not working. Yes. All politics, I'm going to translate that. They didn't put it this way, but I'm going to use my other home, Boston, a Tip O'Neill quote, right? All politics are local. It's crucial that we begin to think that way. And they only that was the only way they were thinking. That was very, very clear. They made a statement that was contradicted later, which was that they made a statement that the state cannot act on remote sensing. California cannot act on remote sensing. They clearly said that it's not the state's issue. In fact, they push it back again to us and said that has to come from you guys. But said the state is not in that business. Well, some people have said the opposite, but it's interesting. And they also work under the presumption, sometimes I felt, which I disagree deeply, that the environment and economic development have to be or are at odds. I don't see that. I have never seen that, and there's plenty of evidence that it isn't. So again, it's what I would call the sort of the superficial view of the thing, but I don't believe it can be shown that that statement will hold water. 3, assessing regional impacts. The integrated long-term planning. John Chen repeated water is the issue for the state of California. Went further and say the step we need to take is forecasting. I translate that, if you're going to do forecasting, you need modeling. And that's the important step, and that's a theme. Andrea Donnellan repeated the value of simulations and models to test the questions of what will happen, where things may go wrong, and that, in fact, is very, very true. Steve Margulis focused on snowpack as a particular problem for California, and then he addressed the issue of the trade-offs of uncertainties that occur between, let's say, resolution, higher or lower resolution, and availability of information. Is Steve here? No, okay. Well, I was going to chastise him because he was a former student. I expected him to bring up the issue of integration of data and data assimilation. That is, after all, what he does. So he never used that word in the whole statement. So I was a little disappointed at that. But I think he had it in his mind when he talked about the trade-offs of uncertainty. I just think he was being a little shy about talking about his work. Susan Austin gave plenty of examples about the value and the potential value of remote sensing to California, particularly in the Sacramento-San Joaquin Delta. And then you made a statement that contradicted the politicians. You said the state could get into the business. So that to me was an interesting contrast. There was a discussion about the use of airborne instruments versus space-based, and I have my own opinions about that, but I'll just leave it there. I think they serve completely different purposes, but that's okay. 4, session number 4, supporting the local action, real-time information. Gerald Bolden talked about subsidence, using INSAR to determine that, the many situations and locations where that is occurring, to at least make some reference to Venice. We have done that in Venice, and in fact, that type of information is incredibly useful to quantify the changes. The translation of science, he talked about. How do we communicate science to the public and to the politicians? And that, a lot has been said. And then he talked about scalability, scalability and integrating data of different types. So different resolutions in space and time, different error structures. That's a major, major issue that in one way or another has also has been a theme of the day. Eileen McCauley talked about local issues. Again, we have to go local. Better resolution is required. Ease data access. We must improve our data access, was the statement. And then we went into a discussion of, real time is relative. I translate that. Don't get too hung up whether it's within a minute or it depends on the application, as I think Surush then follow on with. But that was a theme. Philip Regan, transfer information to users, he said. The translation of remote sensing information and science, the example of the fires was a very, very good one, where in fact this is being done. We're not talking of pie in the sky. This is reality. Ability to provide information. We need to develop that more and more. And we need to act now. In fact, the example used was, look, we've just had the fire in here. When the rains begin, we're going to have debris flows all over the place. We better start thinking about possibly predicting what is the danger, what is the risk posed by the situation. We know enough to do that. I've done that myself. We can do that and provide some useful information at this point. So that's a very good point. Surush Surushan talk about the scale and appropriateness of resolution to different applications and information. He made the statement that to him precipitation was the most important variable that dominated a lot of what happens to us as people living on land masses. And to do it well, we need to integrate all sorts of sources of precipitation information. And for doing that, we have to, again, deal with the scales. We have to deal with the different error structures. And I think he implied that he believes strongly on satellite-based precipitation, that when you think of it, it is 10 years old. Satellite-based precipitation started with the TRIM mission, went up in November 1997. I've been engaged on it since then. Extraordinarily successful mission, talking about what we know. Look, before TRIM, our knowledge of the precipitation over 70% of the surface of the Earth was practically nothing, which is over the oceans. It's really an amazing accomplishment, and a 3-year mission is still flying. Took a little bit politicking to keep it flying, but it's still flying. So anyways, it's really an amazing accomplishment. Session 5, building bridges. The next steps in delivering actionable science from space. Karen Cass Green's talk about the operational Earth observing program. I love it. That's a wonderful, wonderful phrase. And in fact, this group had the most wonderful phrases of the whole day, I must say. I think that is very much needed, and I'll expand that again. It is a failure, not of NASA, not of the USGS. It is a national failure. It's a policy failure that it's been known. It's nothing new. Again, I've been hearing it, debating it, discussing it for 20 years at least, and there's no change. Barry and I've been hearing for longer, I suspect. So it's nothing, but we really need that, absolutely. Bill Gale, he talked about a remote sensing gap in terms of scale. Wonderful comment. And then my favorite, community remote sensing. Very catchy, very good, and I believe on it completely. I think this is something that, in fact, with a somewhat of a twist, as I told Laurie earlier, no, I didn't. I told somebody else, I'm sorry. But it's something that Jack Dangermond and I, when we were in the NASA Advisory Council, were pushing NASA to make the next step as the next big thing after we finish with these 15 satellites. It could work, it should work, and it will work. The question is who is going to do it, in my opinion. Laurie talked about GIS and imagery being the same thing, two sides of the same coin. Very, very important, very, very good way of thinking of it. He also had another wonderful phrase, which is the illusion of simplicity. And it goes to the whole issue of the community remote sensing activity, or what I used to call, and I have to tell you, Bill, that if you go back to the NASA minutes, NASA Advisory Council minutes, both Jack and I were talking about virtual Earth before Microsoft took our words. So again, if you expand those ideas, that's the concepts that is going to lead remote sensing and all data and models into the next future step. Molly McCauley had a wonderful, wonderful statement of what are the metrics of value. I think that was extraordinarily good, to the point, that we fail miserably in doing. We many times in going to Congress, even asking for our budgetary support of NASA, we were flailing because we didn't have a clear set of metrics to explain what is the value of what we're doing. You know, how do you quantify it? What does it mean to you, the individual, and to the region? So I thought that was very, very good. I think you also brought a very important thing, is that when we start using these tools for policy, it means money, it means lives, all sort of things. They need to be accurate, or at least we need to understand what is the accuracy, because everybody has to accept a certain common data currency. And you must know what that data currency value is. Otherwise, you'll never reach an agreement on anything. That is the key element, by the way, of international negotiations. If anybody who has ever looked into that and reaching, you know, conflicts of war, is everybody has to agree on the data to begin with. So, but to agree on the data, we must know how good they are, how accurate they are. So I think that sort of summarizes the individuals. Let me end my comments then by giving you the David Letterman pen, a little bit of what I think are some of the main messages. And I'm going to move from the big national to the California level. We lack a national policy of remote sensing and data collection when it comes to Earth observations. It hasn't been there, it is not there, and I don't see anybody developing it. NASA, to their credit, has been pushed and pulled in many different directions with essentially little or no budget, relatively speaking. And naturally, they're saying, look, our mission is not infinite, certainly not with this budget. So they're trying to confine their mission. But the reality is that this handoff to, let's say, NOAA or to other agencies over the long period of time of the operational long-term data collection that is needed for, let's say, climate or any operation has never worked. I hate to put it, but look at NPOS. And there have been worse things. What I'm saying is nobody in our national leadership has addressed that issue and faced it, and what do we need to do, how do we reorganize to address it. Major, major problem. And until we do, I don't think we will get, which is where we should go, which is the operational Earth observing program. We need to take that step if we ever get to that point of having an operational Earth observing program. We need the integration, point number 2, we need the integration of data models. This touches on many things. This touches on the idea of what I call democratization of data. It touches on what I think is a theme. It touches on the community remote sensing, and a wonderful idea. And it touches on the idea of integrated systems. And that was just said a minute ago. We need integrated systems. We're not talking of Earth, oceans, and atmosphere. The Earth is not that discriminatory when it changes. And when you change one thing, it changes the other. And if we're thinking of getting to the point where we can operationally use these things for short and long-term intervention, we need to basically think of these things integrated. Now, to integrate these things, we need to integrate the data, but data alone is not going to cut it. Because the only way we're going to be able to bring together this variety of resolutions, variety of error structures going, variety of scales from point to global, is to integrate to through some sort of consistency forcing mechanism, and that is models. That's what I call models. And to ask also the what if question, we need models. The data alone doesn't do that. So I think that is really, really, really crucial. It's been said a million times. I take my hat off. Google Earth is the pathfinder in that. They've shown that if you provide information and you give the people access to it with the illusion of simplicity, actually the real simplicity, people will use it on daily life. People will use it for everything. So I am convinced that if we take the next step of a Google Earth and make a dynamic Google Earth that embeds the models and integrates the data, people will use it. Build it, they will come. So if it is simple, but I think you have shown that you can do it. Incredibly complicated in a simple fashion. And private industry, in my opinion, is going to do it. I think government is going to supply key information. I agree with you, by the way. I think the U.S. still provides the best and will for the longest time and for free. But industry will ultimately have to take that final step. Go regional and local. Third point, we need increased resolution, some timeliness of information to do many of the things that are useful to us. And it's absolutely necessary for credibility to implement policy that we translate this global stuff that we keep talking about to how is it going to affect me? Because that's the way politics runs. That's the way the assembly person is going to react. And that's the way you're going to convince anybody to pay anything for this stuff. So we need to go that step. It is probably, in my opinion, the most important thing we can do in the next phase of the climate initiative of this country, and certainly in a lot of the things we do with relative to remote sensing. Let me talk a little bit about California. And I'm a newcomer to California, so I don't know that much of California. Found out how to get here. But, clearly, what it was clear to me is that plenty was going on in California relative to using remote sensing. I think California, time and time again, has proven that it's fairly progressive and advanced in using science to do their thing, and to use it to understand the Earth and their environment and to preserve it. So that is clear to me. I heard environmental monitoring, seismic assessment, climate change, landsliding, fires, water, irrigation, agricultural control of water supply and water use. That is a massive, massive problem that has a solution. Back in 1980, I did research on that. I can tell you it can be done. At that point, I put it away. Maybe I should bring it back now. But it can be done. So I think this is something but it's being done to some extent. I think California is doing a lot about it. And then the question is the question that there was a disagreement between you and the assembly persons. Can California do it on its own? Is this something that could be done? Well, if you look at the economy, you would argue, why not? Certainly Nigeria can do it, California can do it monetarily, but it's a different thing, though, because there are issues of nation-state desire to do certain things that California has no need to do, and hence it's a question of how do I use the money. But certainly from a resource perspective, hard to say this at a time when they're cutting my salary, but they should be able to handle at least a significant amount of this, maybe not necessarily because they don't need to put the satellite up, but certainly to do a lot with the information and certainly influence what do you put up and who puts it up and who pays for it. There's a need to implement decision support systems. I think that is a big hole in here and everywhere else. I think, again, California is fairly advanced on that, but as we go to that operations activity, to that operational Earth observing program, if you think of a California operational Earth observing program, then the question is, how do I then ultimately translate the data to the explanation on the imagery, to the guidance of a decision? How do I make a decision? And that is not a trivial matter, no question about it. But the reality is, going back to my number one, that we do not have at the moment a national policy that will even begin to guide any of us on how to achieve that. It's fragmented. If we talk water, it's all over the place. There are agencies that all fight for it as long as it's not going to cost them any more, or they get more money. So in essence, I think that remains to be the number one issue. Once again, thank you very much. I hope that this was a good summary. Thank you.
Thank you, Rafael. And let's see, I guess we're closing now or finish? Okay. I want to say a few things before we let you go. First, I want to thank all the speakers and all the audience for your participation today. Particularly, I want to thank Michelle Judd. Where is Michelle? And all her staff and volunteers and students who helped organize this. I thought I'd close the meeting by making a couple of comments, listening to part of the talks and listening to Rafael, closing remarks. I think we heard good news and bad news today. I'm going to start with the bad news so I can end on a high note. I mean, the bad news is clearly that change is happening, and happening in a major way, be it in our water resources, the environment, fires, oceans, and independent if it's human-made or natural. I mean, we can debate that forever. The problem is that it has a major impact on us. Recently, I was talking with a very well-educated politician, but not believer in environmental change. And we said, what is the whole fuss you scientists are doing about it? I mean, this change has been happening for the last million years, and it goes up and down, and why are you making such a big fuss? And my answer to him was, the last time the ocean rose by a couple of meters, just a few thousand people packed their tents and moved up the hill. If the ocean rises now a couple meters, you have billion people who have to move, trillion of impact on our economy. So the situation is very different. Today, irrelevant what is the reason. Now, the good news is that we can do something about it, as you heard today, both from our scientific knowledge, technological capability, observational capabilities that we have today. We have the power to do something about it. And more encouraging recently is that the public and our political leaders are becoming more conscientious about this issue, and they want to take some action about it. I'm particularly encouraged when I talk with young people who are getting really concerned about the global change. And I guess when young people start getting really concerned, hopefully their parents and grandparents who run the country become also concerned, about it and will do some action. So I think the challenge on us scientists and engineers is to be able to take the scientific data that we collect and the information that we collect and really present it in what I call a sound, factual way, not political way in any form and not emotional way, but just factual way, and to present it in a way that the politician and decision makers can use it and they do some action. And that's what the topic of today is, that actionable data, that then they can take it and apply it so we can do the changes that we think, or the policies that we think are needed. So in closing, I think this is a kind of meeting which will help in that situation where we bring policymakers, politicians, be it local or regional or global, bring scientists and engineers so we can have this kind of a discussion. So we are aware about, about the issues. And I want to close by thanking the Keck Institute and the Keck Foundation for making this kind of meeting happen. So thank you very much and enjoy the rest of your day.